Hi, my name is Amber Hunter, and for the Chemistry 108 course final project, my element was lead. So the element lead is represented on the periodic table as Pb. It has an atomic number of 82. So lead has 82 protons and an atomic mass of 207. So its average number of neutrons is 125. And since this is its stable state, the proton number is equivalent to the electrons, and therefore lead has 82 electrons. Lead is found in the Earth's crust, where it is often found in molecular form with other elements, namely oxygen and sulfur. Also, lead can be formed through nuclear reactions, such as neutron absorption and the decay of heavier radionuclides. Until relatively recently, lead was commonly used in metal mixtures, and in this way continues to be found in trace amounts in many products and pipelines, which will be expanded on further in the presentation. The natural abundance of the four stable isotopes of lead are as follows. Lead-204 is 1.48%, lead-206 is 23.6%, lead-207 is 22.6%, and lead-208 is 52.3%. The earliest record of lead being mined was in Turkey, starting in 6500 BC, and the Romans became the first mass distributors of lead. By the 18th, 19th, and 20th centuries, when lead began to be considered harmful, the lead had been mined and incorporated into so many products that it could be found throughout the world. Today, the 5 largest lead mines are located in Australia, Bulgaria, and China, but lead can be found in the air, soil, and bodies of water across the globe. As listed before, the 4 stable, naturally occurring isotopes of lead are 204, 206, 207, and 208. In particular, the lead isotopes formed by heavy radionuclide decay are as follows. Uranium decays into 206, thorium decays into 208, and actinium decays into 207. These particular isotopes of lead are important since they will form part of the byproducts in nuclear reactors and the nuclear fuel decays. Also, these stable isotopes are used in lead shielding for radiation shielding. PbO2, found in nature, is produced from Pb3O4 by oxidation with chlorine. When heated, it decomposes and yields oxygen and lower oxides of lead. PbO2 is often used as an oxidizing agent in dyes, chemicals, pyrotechnics, and matches. 3 common uses for this element are radiation shielding, pyrotechnics, and matches. An interesting property of lead is its ability to shield radiation. Due to its high density, the atoms in lead are packed very close together, making it hard for radiation, especially neutrons, to get across this material. Rather, the radiation collides with the atoms in the lead, losing its energy within the material. In this way, lead absorbs the energy of the radiation and protects whatever is on the other side from possible harmful effects. Neutron radiation in particular, fast neutrons especially, which have very high energy, require much more material to be shielded. If you can imagine a single neutron, a tiny little molecule traveling 10,000 kilometers per second, how would you stop it? This is a tiny particle that is uncharged. Traveling this fast, this particle can go straight through the comparatively huge empty spaces within atoms and any material. Having more densely packed atoms, like highly dense lead, increases the chance of a neutron hitting a nucleus and being stopped. Lead's characteristically high density therefore makes it an ideal material for shielding radiation, since even when you have a thin piece of lead, the high number of atoms will allow for better stopping power. One way lead impacts my life is through my research. I do research on high-energy radiation, and I often use lead shielding to protect myself and coworkers from the generated radiation of the experiment. My last experiment included fast neutron generators and detection. The fast neutron generators were placed in a tube, and this tube was surrounded by a lead wrap, leaving only a small opening in this coverage. The purpose of this was to allow the generated neutrons to be collimated to better control where they travel. In other words, the lead surrounding the neutron generator target prevented neutrons from exiting except at one point, allowing for this isotropic source to become directional. This experiment was located in a far corner of the warehouse I do research at, but the control computer was relatively close to the experiment. Therefore, additional lead shielding was placed around the generator detector setup. In this way, the neutrons are directionally emitted towards the detector from the lead wrap, and then all of the neutrons are stopped in a much thicker lead brick wall to protect the operator from stray neutrons, as well as many of the byproducts from the neutron generator, including X-rays and gamma rays. Another way lead impacts my life is through the hospital. Lead poisoning, while not common today, as it was in the past, is still a prevalent health problem, especially for those in older homes, where there may be lead in pipes or paint, which could cause many health issues. I saw a video of a hunter who seemed to be quickly dying, and the reason was a mystery. After an imaging study, it was found that the hunter had several small spheres of unknown origin throughout his digestive tract. After opening up the hunter in surgery, the spheres were found to be lead shot. The conclusion was that the hunter had just hunted squirrels with bullet shot that contained lead. There was still lead shot in the squirrel when he cooked and ate it, leading to the ingestion of lead, and the hunter began suffering from lead poisoning. Once the lead shot was removed, the hunter was treated for his symptoms and kept living a normal, healthy life. A third way lead impacts my day-to-day life is while soldering. Traditional solder is made from lead and tin, and while the solder is melted by the hot iron, the lead is released within fumes, which is why it's important not to breathe in these fumes. At work, it is required that you wear protective glasses when soldering to protect from splattering or a flying piece of cut metal wire, but also to prevent the fumes from entering your eye and being absorbed into the body. Further, it is important to keep either your head off-center of the solder or ideally wear a mask in order to prevent the inhalation of lead particles in the solder smoke. Further, if soldering for a long time, it would be beneficial to take many breaks to ensure that you are not breathing in any amount of lead-containing fumes for a long period of time. And this was my presentation on lead. Thank you.